Hello, my name is Aarush Patel-Raman school from grade 7 and today my topic is Newton's Cradle. This is how it looks and I have used pencil, cardboard, thread and marble to prepare it. First to understand this we need to know what is law of conservation of momentum and what is momentum. Momentum is the quantity which is used to define the state of motion of an object with non-zero mass. It is defined as mass into velocity where p is the momentum. Now, law of conservation of momentum states that for two or more bodies acting upon each other in an isolated system, the total momentum remains the same before and after the collision or any other change, unless an external force is applied to it. Now, after knowing this, let us take a closer look at the Newton's Cradle. One more principle that applies here is law of conservation of energy, which states that energy can neither be created nor be destroyed, but just it changes its forms. So, when we lift it, it gains potential energy, and now when I will release it, it will be changed into kinetic energy. And let us see the impact. As you can see, the other ball from the other end was displaced. What happens here actually is when it collides, the momentum and the energy are transferred from this ball to this ball and so on until it reaches this ball. When it reaches this ball, it oscillates and gains kinetic energy, and when it reaches this side, it gains potential energy. And this cycle is repeated. Now let us try one or two variations. Now when I will oscillate these two balls, let us see what happens. As you could see, the two balls oscillated. To see a clearer picture of what happens in Newton's Cradle, let us just take these three balls. As you can clearly see what is happening. Now, let us understand law of conservation of momentum by using two balls A and B of mass m1 and m2 and initial velocities of u1 and u2 respectively, and let them collide. When they collide, A exerts a force F on B and B exerts a force minus F2, which will be same in magnitude as the force exerted by A on B, but just its direction would change, because in the third law of motion, Newton stated that every action is an equal and opposite reaction. So, both the forces are equal, but if we take this direction as positive, B will exert a force in negative direction. And after the collision, the velocity of A, let us consider it to be V1, and that of B, let us consider it to be V2, mass will be the same. So, we can write F is equal to minus F2. Therefore, as F is equal to ma, we can write ma is equal to minus ma. Now, as we know that acceleration is equal to change in velocity upon time, we can write and substitute the formula as m1 multiplied by u1 minus v1 divided by time is equal to minus m2 multiplied by u2 minus v2 upon time. As time is the same, it will be nullified. So, after some calculations and rearrangement, we get m1 u1, which is the initial momentum of A, plus m2 u2, which is the initial momentum of B, will be equal to the final momentum of A plus the final momentum of B, which is m1 v1 plus m2 v2. So, we can say that the momentum before collision is equal to the momentum after collision, and this proves the law of conservation of momentum. But have you ever wondered that in a vacuum, the Newton's Cradle would never stop because there is no air resistance to stop it? Thank you.